This is where we left off last time. Let's erase some of what we did here. Now, we had looked in our previous video at estimating the voltage of the supply by multiplying the vertical settings in volts per division by the number of divisions at the height of the waveform. Now remember, it's peak voltage. I didn't mention it in the previous video. It is peak voltage that we would have been estimating, right? Not the RMS. Now, what we want to do is look at the horizontal division, all right? Horizontal division. The divisions are in milliseconds per division. The settings would be in milliseconds per division, all right? Now, before we look at numbers in milliseconds per division, let's look at something here. Let's review something. If we consider, for example, this cycle here, and let us say the frequency of our waveform, let's say we know the frequency already at 50 hertz. All right. What will be the period of the waveform? I'll use a smaller pinpoint. What will be the period? Now remember, 50 of these cycles take place in 1 second. So if 50 cycles are seen in 1 second, the period is how long it takes one cycle to be completed. Well, if you have 50 of them in 1 second, then one of them occurs in 1/58th of a second. 1/50 seconds. Which is what? 1/5. 150 0.2. So 1/58 is 0.02 seconds. Alright? Now, it's not really convenient to be measuring this in seconds. So you use milliseconds. How many milliseconds is this? Well, you multiply this by 1,000. Say 1, 2, 3. You're going to have a 0 in front of the 2. So it's 20 milliseconds. Alright? So it's 20 milliseconds. So you can see that from here all the way to here takes 20 milliseconds. Now, here, if we should consider how many divisions are between here and here, that's, well, 1 whole, 2, 3, 4 whole divisions. Look like 5, half and half. Call it 5 divisions. Right? We have 5 divisions for the cycle. The settings in order to show this wave would have to be 20 milliseconds over 5 divisions, which would have to be 4 milliseconds per division. Alright? Now, let's suppose we did not know that. I will put it at 4 milliseconds per division. And we did not know all of this. What would happen? Alright, let's see. What we really are trying to do with the horizontal axis is to find out what is the frequency, or estimate the frequency of this waveform. Now remember, as I said before, You can use the oscilloscope to estimate the voltage, the peak voltage, right, as was in the previous video. And of course, after you find the peak voltage, you can calculate the RMS voltage, right? But here, you can also use it to estimate the frequency. You have meters that can measure the frequency, right? But you can use the oscilloscope to estimate the frequency. Suppose we have this wave and it's 4 milliseconds per division. What you can do is say how many divisions you have here. You have 1, 2, 3, 4 whole division, 4 plus. Alright, so it's 4 plus. This looks like about half plus, and then this looks like another half. So you have 4 plus 1. 5 divisions. So you have a total of 5 divisions here. Alright? Now, this is milliseconds per division. So, how many milliseconds does it take to complete that cycle that covers 5 divisions? Well, each division is a millisecond. So you have 1 millisecond, 2 milliseconds, no, one next another millisecond, and so on. So at 5 divisions, you have 1 millisecond plus 1 millisecond plus 1 millisecond plus 1 millisecond plus 1 millisecond. That's 5. In that case, oh, it's millisecond. No, mistake. Alright, let me do that part again. My. It's 4 milliseconds per division. This is one division. You can see the box here. Alright? These boxes are somewhat faint. But, for example, this box. Let me draw this box here. You can see it more clearly. So you have one division here. Alright? So here now, you go 4 milliseconds. So from here to here is 4, and use a smaller point. 4 milliseconds from here to here. Now you have another 4 milliseconds from here to here. That's 8. Another 4, another 4. So you have 1, 2, 3, 4. 4 fours, that's 16. And then one more to make 17. So here now, you have 5 divisions, 4 milliseconds per division. What do you do to get the period? The period of this wave is equal to, it's going to be 4 milliseconds per division multiplied by 5 division. Division will cancel division, leaving milliseconds. How many milliseconds? 4 times 5, 20 milliseconds. So it's 20 milliseconds from here to here. Alright? 20 milliseconds is equal to 0.02 seconds. Now the frequency, I'm running out of space. Let me go down here. So the frequency of this wave is 1 over the period, 0.02. 1 over 0.02 is how much? Let's draw for our calculator. So we have 1 divided by 0.02 equals 50. So it is 50 hertz. Alright? A frequency of 50 hertz. So you see that? Suppose now you have another situation where you have a different setting. Let me erase some parts of what we have here. Erase some of these things here. Suppose we had, say, 2 milliseconds per division. We had set it at 2 milliseconds per division, and you look at this waveform here. Let us now consider, let's see now. All right, we still use that line. Let's not erase it. And we count the number of divisions. 1, 2, 3, 4 whole divisions. Half here and half here. All right. So we have 5 divisions. And we have 2 milliseconds per division. So the period would be, so the time it takes would be 2 milliseconds per division multiplied by 5 divisions. Division cancel division. So 2, 5 is 10 milliseconds, which is 0.01 second. All right. 1, 2, 3, 0.01 second. The frequency would be 1 over 0.01, which is what? 1 to 100 hertz. Well, you know, that wouldn't be coming from the mains frequency where we are, because we use 50 hertz. But 100 hertz could come from some type of signal generator or so. All right. So that would be 100 hertz. So there we have a method of estimating the voltage and the frequency from looking at the oscilloscope screen.